So little change of order. We will have a panel discussion at the end because there are multiple various frontiers which will be open to you. So Dr. John Davis Akkara will be going second. He is going to talk about using 3D printing for your innovation and how to rapid prototype your innovation. So over to Dr. Johnson.
Morning session. I think maybe a few people went for the glaucoma walk as well. I'm Dr. John Davis Akkara. Thank you to Dr. Nilesh for organizing this session. So like he said, for the past 3 years we have been doing this session, and it's something which is an unmet need. And so I hope we get more audience. So while tech is being sorted out, I'll just tell you about the innovator mindset. So like Dr. Nilesh said, you need to love your idea. You need to you need to believe in it. You need to figure out so many things about it. So that's something which all innovators, all people with ideas need to know. Sometimes you get failures, and you need to work through them. Okay, so I'll just start off with one very useful skill that will help you to bring your ideas to reality. You might have a lot of ideas, and you might be able to go to an engineer and talk to them and get it done, but it is very useful to at least know the basics of some of these technologies so that you can prototype these things yourself. Because there is always a gap. When you have an idea, you need to go find somebody, talk to them, translate what you are talking to the language that they understand. And I'm not talking English, Malayalam, Tamil, Hindi. It's a different language. What doctors speak and what engineers speak are actually not the exact same language. And if you know how these things work, the basics, then you will be able to better understand how to communicate, what are the things that are easy for them to do, what are the hard parts, what are the small things which will add a lot of value to your product, things like that. So 3D printing is one very useful technology which you will need to know. In addition to software development and smartphone app development and other things. So let's start. If you notice, this is a 3D model of a chopper, and the newest version of PowerPoint can incorporate that as well. So you can import 3D models. You can download 3D models from my pages on the NIH website, that is 3d.nih.gov. You can scan this QR code if you want the website. And on the right side here, right side, anatomical left, but right side, you have the QR code for Thingiverse page. And financial interest, I am developing some products in this which I am going to commercialize, and many of the other things on these pages are free, open source, so that will come under the Creative Commons license, CC BY. Most of that is, you just need to attribute, that's all. So you can use it for yourself, you can use it for commercial purposes also, but you can use it. So again, 3D, if you want to put 3D models in your PowerPoint presentations, you can do that also. That will be the first step. Okay, you just download it and put it in your PowerPoint presentation. Insert 3D model from device. Got it? So 3D printing is a technology where physical objects are created from digital files. So this is very confusing to people who are new to 3D. They think that maybe you take a 3D photograph and print that. No, you create things. So if you say 3D printing, it might confuse people. This is 3D manufacturing. It is additive manufacturing that we are using in 3D printing, and subtractive manufacturing is used for CNC machining. That is, you take a block of metal and the CNC machine cuts out the parts which are not required. That is subtractive. This is additive. That is, you don't waste any material. You put layer by layer and make a physical object. And there are many techniques. So fuse deposition modeling is the most easily available one. It uses filaments, and this is how it works. You design something, you use software to slice it, and you print it technically print, then some of the things you need processing. So, for example, if it's FDM, not much processing required, but you do processing, you can get a much smoother finish, much better devices. You can actually, instead of taking it as a prototype, you can take it as a final product if you do finishing it properly, post-processing properly. Resin needs a little more post-processing. So materials used, the most common materials are PLA and ABS. You can use nylon, PT, you have flexible materials, so many options. You even have wood. So you have sawdust incorporated in PLA and gives you a wood-like feel. So you can actually print wood, okay? And you can print in titanium. But that's not an easy thing. You need a more expensive printer. You need titanium dust, but it's definitely possible. Okay, so if you look at the easily available techniques of 3D printing, that is, one is the FDM one, and one is the SLA, that is the resin type. So these two things are very inexpensive. The cheapest ones of FDM are 15,000 rupees, whereas the cheapest ones of SLA are 20,000 rupees. So it's cheaper than a smartphone. You can just gift it on somebody's birthday. My birthday is coming up, okay? And so it's a disruptive technology, and you can think out of the box, and you can think of a design, test it out. If it doesn't work, you can go back to the drawing board immediately, change it, and so that process of iterating designs becomes much easier with this technology. And mind you, there are 3D printers on the International Space Station as well. So if somebody on the space station says, oh no, this thing broke, people here on Earth are going to sit and figure out a way to fix it. They're going to develop the design, they're going to email it to them, they're going to print it there on the space station and use it. So that has happened. They have had some emergencies on the space station where they broke a screwdriver, and they said, wait, we will develop a new screwdriver and send it to you. And it's very useful in education. So you can actually have these 3D objects for anything. So I'm just going to go through this quickly. 3D printing is very much in use in architecture and the business of real estate. You can have 3D printing in construction, in the sense that there are now 3D printed houses which print with concrete. So that is very much there. IIT Madras did it recently. Several other engineering colleges in India are doing this one by one. I missed a few, but past few months there have been a few more. So this is in India itself. So think what is happening in the rest of the world. A lot of companies are 3D printing engines also. So they are doing 3D printing in titanium for engines, even in automotive industry. And then the main thing is it helps you in iterative design, quick iterations. Even food, you can 3D print food, okay? So if you yeah, maybe if you love cooking, maybe you should learn 3D printing so that you can 3D print food in the shapes that you want. And outer space, definitely very useful, because you cannot send something from Earth to there. So you might order it from 3D printing Amazon or something, and it would print on the space station or on Moon or Mars or wherever we are going to be in the next 10, 20 years. Dental industry, yes, dental is very much into 3D printing, lot of 3D printing happening there. So now we saw all the other industries. Let's go to the main part, which is ophthalmology. Okay, so much, so I'm skipping. Bioprinting is also there, skipping. Now we reach ophthalmology. So ophthalmology, everything from the cornea to the retina to the external accessories, that is the gadgets which we make, planning, surgical planning, everything can benefit from 3D printing. I have an article in Kerala Journal of Ophthalmology where I have documented a bunch of 3D printing, uses of 3D printing in ophthalmology. Kerala Journal of Ophthalmology, this article. Then we have done a few other 3D printing projects also which we have published. And of course, in Arvind Eye Hospital, the last day of my fellowship, we got a 3D printer. So we have been asking for a 3D printer for quite some time. They said, no, you send it off to Aura Lab in Madurai. They will print it and send it back. We bothered them so many times that finally they said, you buy it yourself. We give you the money, you buy it and keep it there. So we just got the 3D printer on the last day of my fellowship. We printed a fundus camera and gave it off to so the next day was the hospital day. So it was given to the chief guest, Dr. RDR sir, on the hospital day from the 3D printer which arrived the previous evening. So that was there, and after that there were so many 3D printing projects done in Arvind. This is one of them, 3D printed eyeball for practice of wet lab, for lasers and whatnot. And there was one which it can be, it's flexible here, TPU material, so you can practice indentation in direct ophthalmoscopy. So this is flexible material. So you have different materials available. So if you have ideas on something to make, you just figure out what can be done. And if you know that this technology of 3D printing has this option, you can do that. You will be able to think better. You will be able to try out your ideas and figure out better ways to do things. So this is a 3D printed smartphone microscope adapter which we had done with Dr. Ahmed Ateya. This is the world's first open source smartphone based retinal camera. You can just download and print it. That's there in ODocs. This is the ODocs one. This is the first one which we printed in Arvind Pondicherry. So we just downloaded it, printed it, gave it off in the inaugural, in the hospital day. And then indirect lens adapter. There are multiple 3D printed and otherwise fundus adapters. So many are there. And this is a slit lamp. So anterior segment also, you just need a lens inside and you can take anterior segment photographs. And now Peak has a retina device as well. All these commercial wet lab model eyes are also 3D printed. So if you want to, you can 3D print them yourself or you can buy it from them. This is printed by Dr. Uh, Prashant Girish, again Arvind Eye Hospital, Pondicherry. So this is that model. He was an IOL consultant with me. And then let's go on to, sorry, skip these things. Yeah. And this is again my website, not my website, my page on Thingiverse where I keep uploading newer designs. So you can just download these. So you can download the Aurolab aqueous drainage implant, you can download CTRs, you can download CTS. But mind you, these are not for human use right now. These are for wet lab practice. You can, or for your PowerPoint presentation. You can put these in your PowerPoint presentations and move it around in 3D. Or if you want to do wet lab practice, you can just download and print these. Or if you want, like I said, iterative design, you can just download one, think on how you can make it better, and please give attribution to me because I put it up, and then make a new design and you can just go for commercialization also. So these are some of the 3D printed glaucoma drainage devices which I have done, and that was a BHEX. This is a project which was done by MBBS students. I was in Ramchandra Medical College in Chennai, and the MBBS students there were interested in doing, they were basically bored with ophthalmology. So I taught them 3D printing as well. I told them that these are the options available, and they said, okay, we'll do some project. I told them, you search on PubMed or something, find out some ideas. They said, okay, there is something called a punctal plug. I said, yes. What do you want to do with it? Can we 3D print it? Sure. And they designed a punctal plug, and we 3D printed it, and we were able to use that. So, and this is the other thing. This is a glaucoma drainage device which I had developed there. So again, done completely by YouTube learning. Learned all this 3D designing from YouTube. And of course, you can use 3D printed designs for contact lens fitting. I'm going to quickly go through this. Okay, this is Dr. Prasanna Venkatesh's 3D designs for the circle of Willis and the whole assembly of, this is for teaching basically. So these are 3D printable. You can paint it, do post-processing so that it looks blood red. You can polish them if you want to. You can do all sort of things with these. And of course, many more 3D printed smartphone fundus cameras came out, including this ogle scope and the C3 MedTech, which was on Shark Tank. So there, all these things are available. Okay, and then what I did was I made an iterative design. So already there were 3D printed smartphone fundus cameras. I made another one, the foldable fundascope, which is a 3D printed one, which folds and fits in your pocket. Okay, So I found the last mile problem was that people were lazy. People are lazy. Okay, so if you give them a fundus camera, a smartphone fundus camera, which is portable, okay, it is definitely portable. You can carry it around. They are too lazy to carry it around. You need something which can fit in their pocket so that they don't have to worry about carrying it around also. They forget that it's in their pocket, and then suddenly when they need to take a fundus picture, they just put their hand in the pocket, take it out and take a fundus picture. That's how lazy people are. And that's a fact. So people are lazy. If you give them the entire do-it-yourself thing of how to make a fundus camera, they don't do it because they are lazy. Okay, not all people, but many people. So I'm not talking about the innovators here. So many people are lazy. So this is how I designed it. During lockdown, I had nothing else to do but sit in Ramchandra Medical College with no patients in the OPD and watch YouTube videos. So this is what I learned during that time. And I happen to have 3D printers in the dental department there, so I use those 3D printers. And in fact, there was an there was an engineering college also, so I got to do some artificial intelligence work as well. So that is about the 3D printed fundus cameras. Then you can use it for orbit work as well. You can practice surgeries. You can all these 3D printed models can be used. You can plan radiation treatments, so ocular oncology. I think Dr. Swati will be talking about some of, not this time, but maybe she will be doing this sort of work as well. You can even 3D print an OCT, because this is not practically of any use, but if you ask what can be 3D print, you can say, yes, of course, you can 3D print your OCT also. So just to demonstrate what it looks like, this is probably what is very interesting and very useful for many of you. If you want to develop a 3D printed surgical instrument, you just draw it and then print it, test it out, figure out what works, what doesn't, change it, again come back to the drawing board, which is again your laptop, change it again, print it again, change it again, print it again, and figure out what works. When you finally have a design that works, you go to the company or you patent it, and then you go to the company and you manufacture it. So that process becomes much, much faster. It was never this fast maybe 5-10 years back. So this is the best time to make instruments. So this is one such instrument, a 3D printed transconjunctival vitrectomy trocar cannula system. So very simple design, but you can test it. This is Dr. Sergio Canabrava. He also said that he 3D printed the design first to get it in the correct design. And then of course reconstructive surgeries, you can have 3D printed templates to use. So all these things, I think oculoplasty is going to be using all these things. Orbital limb, everything is oculoplasty now, so I'm in that section. And then teaching tools are so many, like Arvind Eye Hospital did a lot, and of course there are prosthetic eyes. I'm going fast because I am taking a bit of time, so I am going to skip over the spectacles because everybody knows spectacles. LVPI did Fittle, which is a puzzle for blind kids. And you can 3D print lenses also, not with the regular printers, but you can. So LuxExcel company has been 3D printing lenses also, just because they can. It's not cheaper, but yes, you can do it. You can bioprint corneas. So this is by a UK team in UK. A Korean team also has been doing it, and now LV Prasad Eye Institute has 3D printed corneas. So that is something which I got to know last week. And I think a Bangalore team is also doing 3D printed corneas. So North Carolina, so everywhere, India is not behind. We are doing it in with the same rate, same technology as Korea and UK and USA. So this is Pandorum in Bangalore as well. So that is going to solve a big problem. So cornea people are going to be happy with that. Retina, you can 3D print retina. Accessories for patients to put eye drops. This particular thing is an eye drop helper. This is by Dr. Shivagami in Arvind Eye Hospital. And this is, again, I went back to the same thing. So then we have a microscope simulator to show the patients this is what the lights look like when you are under the microscope. So when you're doing topical phaco, you tell the patient, see, look at this light and this is how it's going to be, don't worry. So you just prep them before surgery. So counseling patients, Arvind Eye Hospital again. And this is another design of an eye drop helper by Dr. Pawan. So Dr. Pawan is also a glaucoma specialist. he devices for patients with glaucoma who are not putting their drops properly. So thank you for this wonderful opportunity, Dr.
Thank you, Dr.
Nilesh.
John, for that wonderful talk. And we have a 3D printing course going on in TSTC from 10 to 11:30. Dr. John is taking that. We have a 3D printer over there. 3D printing team is over there. So anybody who wants to know how to do a 3D printing, a full 1.5 hour course just on 3D printing, and they will help you out. So I welcome everybody who is here to just after this course to come over there and get the